All right, good morning. This week we are going to start moving into some major word problems and what's called solving the triangle, which is a full version of what we've been doing, kind of building up to. All right, so we will now be using inverse trigonometry in our triangles. So later on, we'll start taking a look at some word problems. But first, I wanted to just introduce you to normal solving for angles. All right, because last week we ended off, I believe, with, where is it? With evaluating them dealing with regular trig, right? But we didn't see something where we had to solve for, oh, excuse me, sorry, solve for an angle.
Bless you.
Thank you. So a very basic example we see here. I want you guys to find theta. And this is, you're given a triangle, you're given a situation. So there's two things you're going to do. Okay, and they're very similar to what we did with trig. The only difference is there's that extra step where we have to use inverse trig. Now, once you're comfortable with this, or if you're already comfortable with this, you can jump right to the inverse trig part. But I like setting it up first and then going through the steps of solving just to make sure that we have everything in the right place. We have everything labeled correctly. So again, when they give you your angle, when they tell you where your angle is, then with this as your reference, we can label the sides, right? Opposite, adjacent, hypotenuse. Right, so the first thing that you're going to do once you have your triangle set up, whether it's given to you or if we set it up ourselves in a word problem like we'll see in a little bit, label the sides given. So here is our theta up here in our upper angle. So this 8, that is my longest side. It is across from the 90 degrees. So I'm just going to put an H next to that for hypotenuse. The 5 down here, be careful. Normally, we've seen that as our adjacent side. But now my angle is up here. So the 5 is across from the angle. So that is my opposite side. Just so we have them all, I'll put the A over there just for the adjacent. When you're asked to solve the triangle, what that means is find everything that's missing. All right, and we'll take a look at that maybe tomorrow or Wednesday. So solving the triangle, I would find this angle, and that side. All right. So labeling this might come into play later to help us. So now that we have our sides set up, we're going to figure out which trig function do I need to help me solve for this. So here's my angle. And what we know is the opposite and the hypotenuse. All right, so we're looking for what trig function gives us a relationship between the opposite, the O, and the hypotenuse, H. All right, well, in SOHCAHTOA, the O and the H is the first part. That's an O. So that's telling me that the sine of this angle gives me the relationship, the proportion of the opposite over the hypotenuse. So first, I'm just going to write the rule. All right, so sine is opposite over hypotenuse. Now we're going to plug in what we know. So we don't know theta, so that's going to stay theta. The opposite is 5. The hypotenuse is 8. Now you can make this a decimal if you'd like, or you can keep it as a fraction. Honestly, it depends on what you're using as a calculator and what's easier to plug in. In your calculator, if it's easier, if you have a good way or an easy way to do fractions, then use that. If you don't like punching in fractions into the calculator that you have, then make it into a decimal. All right. So now we want to find our theta. So officially, what we do is we have to do the inverse of our sine, right? So I take the inverse sine of both sides. So on the right side, right side, I have inverse sine of theta, right? And we learned last week that those are inverse, so they eliminate each other, and we're just left with the theta. You could write arc sine here if you want, but like I said last week, I'm going to be using the -1 just because it's a little quicker than writing the whole thing out. It's not saving much time, but right. So we have the angle is equal to the inverse sine of 5/8. So this is what we would plug into our calculators. Now, if we're dealing with triangles, okay, just a word of advice, most of the time, that up a little bit, most of the time we are going to be in degree mode. Okay, if you're dealing with normal angles, if they talk about, like we'll see in a little bit with the word problem, angle of depression or angle of elevation, or just, again, general triangle stuff, the majority of the time we use degrees. If they say find it in radians, then obviously find it in radians, right? So for now, though, I'm going to stay in degrees. So again, to get the inverse sine on a calculator, you're going to hit the second button, and then you're going to hit sine, and it puts the sine to the -1 there. Now with this, I can just type in 5 divided by 8, and that's good enough, right? And if you have like one of the lesser calculators too, okay, you don't have to punch in the fraction. You can punch in 5 divided by 8, and then you hit enter. So the angle made up by those two sides is going to be about 38.7 or 38.68. And again, we're talking about degrees there, so we got to make sure we put the degree sign.
So we don't round?
Sometimes they'll tell you round to the first place. So if you told me 38.7, you'd be fine.
Okay.
But usually we want at least one decimal point. If I just said 39, that's not as accurate. Okay. Right, and then if you wanted radians, right, just make sure that you're switched over in the mode to radians. Don't worry about putting a pi. Just put whatever they give you. So real quick, just to show you, put that in radians. Calculate that again. You would just say 0.675 or 0.68 radians. All right, so what I was saying before is once you get comfortable with the inverse and in trig in general, okay, you can skip all this stuff and you can just write the relationship flat out, right? So once you get comfortable, you could just, once you become familiar enough with trigonometry, right, you could just write this out and calculate this without setting up everything. But if you're still, a little weary with it, if, you need more practice with trig, I'd write everything out and then go through the steps and solve. All right. Would you guys like me to do another example with just the numbers like this, or can we move on to word problems?
One more example won't hurt.
Okay. All right. Nothing wrong with that. Where is my other whiteboard? All right. I can take this away. You're good with it?
I wrote it down.
Okay. So let's look at another example. All right, so here we have another triangle. Okay, a right triangle. We have the legs are 10 and 11. We want to find our theta, our angle. So actually, I'll give you guys 1 minute. You don't have to solve it, but just come up with the trig function that we could use to represent this situation. I'll give you a minute to think about it. All right, so what, given the two sides that we're given, would I use sine, cosine, or tangent for this? Does anybody want to? You can type it
Cosine?
in, or you can say cosine. So we have the adjacent. Okay, so 10 is the adjacent. And then is 11 our hypotenuse?
Opposite.
It's the opposite. So what trig function do we need with adjacent and opposite?
Tangent.
Tangent. Okay, so yeah, so just be careful, right? The way the triangle is oriented, right, may be different. So I drew it like this on purpose to kind of maybe throw you off. All right, so just be careful. It won't always look nice and flat like that, right? You may have a weirder, stranger setup where it's not always straightforward. All right, so using the tangent, I'll do the long way. I'll set it up first. So the tangent is the opposite, 11 over my adjacent, 10. Right? So with our normal trig, we have the tangent of our angle is equal to 11 over 10, which actually would be 1.1. Right? And I'll use the decimal this time just to show you it doesn't really matter. So we want the inverse, right? So if the tangent of my angle is 1.1, then my angle is equal to the inverse tangent of 1.1. All right, that's our swap. We move the tangent over to the other side and we add the -1, the inverse. And again, in degree mode, I have the inverse tangent of 1.1. That's going to get us 47.7 degrees. Right, and you get the same thing if you entered the fraction. Ooh, that sign. Right, 11 over 10 also gets us the same thing. Let's do one more. We'll just focus on this today. We'll do the word problems tomorrow. Erase this. Let me see if we can find. I mean, most of them are pretty similar. Let me just see real quick. Hmm. All right, we'll add an extra part to it this time. So we're going to find the theta, and then we're going to find the other angle. Let's see. All right, so it is 10:51. I'll give you till 10:52 to think about this. So what trig function are we going to use? How are we going to set it up? All right. With our angle being in the lower right corner, the 41. What side is my 41? Opposite, adjacent, hypotenuse.
Hypotenuse.
Hypotenuse. The 23 is what?
Adjacent.
It is the adjacent side. What trig function do we use with the adjacent and the hypotenuse, the a and the h?
Cosine.
Now we use cosine. Right, so we're going to find the cosine of our angle, and that's going to give us the proportion 23/41. Flipping the cosine, we're going to get our angle is equal to the inverse cosine of 23/41. So we're going to take the inverse cosine of 23/41. That's going to get us an angle of 55, we'll say 55.9. So now we want to find our other angle. There's two ways that we can do this. We can put another variable there, and we can set up a new trig function. All right, let me make this actually red. All right, so I put an alpha there. All right, that's our lowercase a alpha. So with alpha here, the 23 would become my opposite. The 41 stays my hypotenuse. Right, so I would have that my alpha is equal to the inverse sine of 23/41. Or, what do we know about the angles of a triangle? What do they add up to?
180.
180, right? So we know two of the sides already. So 180 minus the 90 leaves us with 90. So the alpha would be 90 minus whatever our theta was. All right, so 90 minus 55.9 would get us 34.1. right? And that would be degrees. Oops, I forgot. Just to check, as our last step, let's check the inverse sign of our proportion 23 over 41. And look at that. We get very close to that 34.1. All right, because we rounded this. This was a little different, but those are fairly accurate.
Mr. Murray,
All right. What's up?
why does the adjacent turn into opposite? Like, what does
Okay.
alpha do?
So for the original problem, right, this was my angle of reference. So with this as my angle, this side is both sides are touching. So, but this is the hypotenuse, so the hypotenuse is always hypotenuse. And this would be the adjacent side because it helps make up that angle. When we look for the other angle, okay, I'm essentially removing this. And now this is my reference point. So with this as my reference point, I don't have the adjacent anymore. My adjacent would be this side over here. And the 23 becomes the opposite. All right, so depending on what angle we're looking at, that's going to change our adjacent and opposite. Okay, the hypotenuse is that pivot point where that stays, the hypotenuse. But depending on which angle we're looking at, okay, our adjacent and our opposite will change.
So when they ask for the other angle, we completely like disregard the primary angle.
Right, if you're using trig. If you just do the quick triangle math, you don't have to worry about redoing opposite and adjacent. Okay, but if you are doing trig, right, if for some reason that to find this, the only way was to do some trigonometry, then right, you would disregard the first setup and you'd make a new setup.
All right, I got it. Thank you.
Okay, good question, good question. Anything else? All right, so we will take a look at the word problems tomorrow. We'll push that back. That's fine. I'm going to give you one problem tonight with this, just to get you in the feel of things before we start tackling the word problems. All right, so it'll be a quick homework tonight. All right, that is it for us today. Have a good rest of the day. I'll see you all tomorrow.